Hello, it is I, Dr. Brian Lorgon 111, and we are back here in our Learning Command Blocks world. And you can see behind me this big tall tower. I have added nudgeZ to this world that we saw back in the previous episode. And you can also see back over behind us, back from episode 4, we made this little checkerboard pattern. And then I gave you guys a homework assignment to do a similar kind of thing where you draw a very interesting pattern called Sierpinski's triangle. And we are going to build that today. And in the process, I'm going to teach you a bit about debugging, because for those of you who may have tried to do the homework, some of you succeeded, perhaps some of you didn't, you'll quickly discover that the act of programming is very much the act of debugging what you've already written in order to fix all of the errors that you introduce. And so today's episode is going to focus on debugging and pragmatics and teach you some different ways that you can figure out what's going on, or more importantly, figure out what's going wrong as you're trying to build big and complex things. So just as a reminder, in terms of the programming task for the thing that we're going to draw, I explained last time that basically for any given square that we are trying to decide what color it's going to be, there are actually 4 different possibilities based on looking at the color to the left of it and the color above it. And so here, if I map out the 4 different possibilities, I'm going to look one up and one to the left, and they could be both white. One could be black to the left, one could be black above, or both of them could be black. And the rule is going to be if exactly one of them is black, then the current block that we are at, we are going to color black. And if 0 of them are black, or if 2 of them are black, then we're going to color the next block white. And so that is the rule. We're going to look up and we're going to look left. And if exactly one of them is a black block, then we're going to place black wool there. Otherwise, we're going to place white wool there. And that will be our rule for populating the next square of the thing that we're drawing. And so we just need to encode that, and we need to do a similar thing we did last time, where the armor stand just goes down, and when it gets to the end of the row, it goes down to the next one and just keeps moving across. So let's try to build it. Before we actually start laying out command blocks, I have on the scoreboard on the right side of the bar, you see a bunch of leftover scores. And so I'm going to say scoreboard players reset star, which will basically erase all the players' scores from the scoreboard. The my objective that was over there still exists. It's just that there's no players with scores in that objective to display. And so we'll see them pop back up on the sidebar once we actually populate some scores. And just like last time, we're going to do a similar type of thing where basically we have some initialization that we'll do, and then we will program a loop that goes and tries to populate all the wool blocks. And for initialization, once again, we need to count until we get to the end of the row. I had suggested, some people had asked me, because I didn't specify in the homework problem, how long each row should be, and 64 blocks is a good length. And so I'm going to say scoreboard players set, I'm going to have a variable called x in my objective that I'm going to set to 1. And before I even do that, just a reminder, I am facing right now towards positive x with the rising sun in the east, and I am building my command block rows in the positive z direction, which is the direction that I encourage you guys to build in. And that'll be useful if we need to use the nudgeZ tool, which we probably will. But I'm going to set x to 1, and I also want to summon an armor stand. So I can say summon an armor stand, and I will do it, I guess, like 6 blocks over in the x direction. And are there any other initialization things? I guess I'll go ahead and place down the first block above the armor stand as well. So I'm going to execute at e type equals armor stand tilde tilde tilde, and I will do a set block of tilde tilde 3 tilde wool 0, which is white wool. And so basically at the location of the armor stand, 3 blocks above that, I will place a piece of white wool. And before I test that out, I also noticed that I have one armor stand over here already. I'm just going to break it manually. But let's go ahead and run this just by putting some redstone down. And we summon an armor stand over there, and we put a piece of white wool above it. So our initialization works. And so we've got the first square of our little picture done. All we need to do is draw all of the rest of them. So I'm going to build this out on camera so that I can kind of explain some of the reasoning I'm going through. I'm also going to make some mistakes along the way, And the mistakes that I'm going to make, I'm going to interject intentionally, but they are actual mistakes that I made while trying to build this. I originally gave the homework assignment about a week ago, and this morning I just tried to build it again myself, and I actually made 3 mistakes while I was doing it, and so that'll present a nice opportunity for debugging things. But basically, the logic is kind of going to go in 3 steps. We're going to move the armor stand to the new location, then we're going to decide what color wool we want to do, and then we're going to actually place the wool. And that's the thing we're going to run over and over again in a loop. And for deciding where the armor stand wants to go to the next, most of the time we'll just be teleporting it 1 over in the x direction, but once x gets bigger than 64, then we're going to kind of like rewind over to the next row. So that's the first thing that we're going to do, is test the value of x. So I'm going to say scoreboard players test x in my objective, and I'm going to see if it has a minimum value of 64 and any maximum value. And so I'm going to run that test. And so if x is bigger than 64, then what I want to do is scoreboard players set x in my objective back down to 1. This is going to be a conditional block that's only going to run if x was up above 64 here. And I am going to teleport the armor stand, TP at E type equals armor stand, to tilde minus 64, back 64 to the left, same y coordinate, and down to the next row in the z, tilde 1. So that's also going to be conditional. So basically, if this is true, if x has gotten too big, we reset x and we move it back and down into the next row. Otherwise, I want to do an else, and we learned how to do an else last time as test for block. In this case, it's going to be tilde minus 3, chain command block minus 1, success count 0. And so basically that's going to look at the block 3 back in the direction I'm currently facing to see another chain command block and see if its success count is 0. And so 3 blocks back will be this test. So if this test succeeded, we'll run this. If this test failed, its success count will be 0. And then instead, we're going to run whatever is over here. And over here, I'm going to say scoreboard players add x to my objective 1 conditionally. So else, if that test was not true, then I will add 1 to x, and I will teleport the armor stand tilde 1 in the x direction, tilde tilde. So just move it over 1 space, and that's also conditional. So if x is 64, then I'm going to reset it back to 1 and teleport the armor stand back 64 blocks over. Otherwise, I'm going to add 1 to x, so make it 2 and then 3 and then 4 in each iteration of the loop, and teleport it 1 square over. All right, so we've done the first part. We've moved the armor stand to the new location. Now we need to decide what color we're going to make the wool and then actually place the wool, are the remaining bits. So to decide what color we want to make the wool, we need to, as I explained a moment ago, look 1 square above it, look 1 square to the left of it, and count how many black wools there are. And so in order to do that, I'm going to have a new scoreboard variable that I'm going to initialize. I'm going to have a new scoreboard objective called count in my objective, and we'll use that to count how many black blocks that we find. And so first, I need to test for the block above the block that we're placing. So I'm going to say execute at the armor stand. And I've been placing the wool 3 pieces above the armor stand. So I'm going to go tilde tilde 3 tilde. So that's the block that we're currently about to place. And then I'm going to say test for block at tilde minus 1, which will be kind of the block above us when we're kind of facing down looking at this thing, for wool 15. And so that'll test if there is a black block above us. And if there is, then I want to say scoreboard players add count in my objective 1. I'm going to do that conditionally. So I'm going to look and see if the block above us was a black. And if it was, I'm going to add 1 to the count because I'm trying to count how many blacks there are. And then I want to do something very similar, and so I'm going to hold down Control and middle click this guy in order to get a copy of that exact block. I'm going to execute 3 above the armor stand in the location where we're about to place a block, and test 1 to the left rather than 1 above for wool 15, which is black wool. So I'm going to test for that, and then I want to get a copy of this block, which is going to add 1 to the count and make it conditional. So I test to the left and I add 1. I test above and add 1. I test to the left and add 1. And then finally, we have computed how many blacks are nearby. And so if there's exactly 1, I want to place black wool. Otherwise, I want to place white wool. And so I will say scoreboard players test count in my objective. If it's exactly 1, if it's between the value 1 and 1, minimum value and maximum value, then I'm going to say execute at E, type equals armor stand. And we're going to set the block 3 above the armor stand, tilde, tilde 3, tilde to black wool. And that's going to be done conditionally if this is true. And then else if this is false. We had another else over here. Recall that I had an if and then an else that looked 3 blocks back. So I am going to control click on this block, just so I don't have to type that whole command again, and paste this block over here. Test for block, except for this one's only going to look back 2 blocks for a chain command block with a success count of 0. Because 2 blocks back is where I was testing if count was exactly equal to 1. So if it's not exactly equal to 1, then I want to take my command over here, and I'm going to control click to copy it and change it to being set wool 0. So basically above the current armor stand, set the wool to white wool. All right, and then I think I've made the logic for trying to run this thing, and so we're going to try it out and see how it goes. So if you're a programmer, you know that this is what we call the moment of truth. We're actually going to try to run the thing. I've already run the initialization and gotten my first armor stand over here. And so right now, this purple block needs redstone to start looping, but I'll go ahead and just activate it with redstone. Oh, no. Oh, dear. This is going to be a hard one to get out of. I'm teleporting all entities, including myself, and not just the armor stand. How do I fix this? Let me think about this for a moment. All right, I've thought about this for a minute. Occasionally you'll do this. I wasn't expecting to do this on camera, where you get the player caught in an infinite teleport loop or an infinite death loop or different types of things that makes it very difficult to correct what you've done in the world. In this particular case, I think I do know a way that I can correct it. And so this will actually be interesting to do on camera. So right now my x-coordinate is going up and up and up. You can see if I look over, someone taught me that I can do F3 and D to clear the chat. And then I can hit T to type the chat, and so I can use my mouse cursor on the screen. But you see my X is going up and up and up and up. So that's the problem. And so I believe what I can do now is I can teleport myself, teleport the player, I want to teleport back to a negative x, so I'm going to have some time. So I'm going to say x of negative 100, and then tilde tilde. My x is still going to go up, but now I'll go right past where the problem was, and I might be able to fix it. So let's do this and figure out, okay, here comes the thing. Blam! Neat! So basically I was standing here and it started teleporting me to the X, and so I teleported myself back over there, and then every tick it was teleporting me back 1 in the X, and when I saw the purple looping blocks, I just started swinging my fist in the air in creative mode, and I managed to break the blocks. So that's good. All right, so we got ourselves out of this little pickle. Occasionally, yeah, you get yourself into a problem where without external tools, it's very difficult to get yourself out of things. I don't have a general strategy for doing that, but in this specific instance, we were able to make it good again. But that was exciting. Okay, so let's try to debug what just happened there. So before we even look inside any command blocks, I do see that the armor stand was also moving and has moved a bit. And so my expectation is that somewhere it was trying to teleport all entities rather than just teleport just the armor stand. So let's pay careful attention to our TP at ease that teleported the person one over in the X direction. And so here's where we tried to teleport the armor stand back over a row, and that never happened to us. But over here, teleport at E, yes. Okay, so it's supposed to say type equals armor stand, and it just says armor stand. And if there's text in here that it doesn't know about, it just kind of ignores it. And so that was the bug. And so it was teleporting all entities, not just entities whose type is armor stand, and the player is an entity, one block over in the X direction. So let's go ahead and correct that. And yeah, let's try to go reset things to their initial conditions once again. I'll go ahead and put a purple block back here at the beginning of this loop. But if I run this, we'll go back to initial conditions, except for we didn't kill this armor stand. So another thing I would like to do is I would like to kill all of the existing armor stands in the world as part of my initialization stuff. And I want to do that before I kind of do anything else. So let's use nudgeZ to insert a command right at the beginning here. I will use nudgeZ right here, which will push these blocks over one. And I am going to add a command that is kill at E type equals armor stand. All right. And so let's actually try this and see that both of these armor stands die, although then we're going to summon another one. Kablam! They did. We summoned a new one. We actually summoned the new one square over because it was summoning relative to this command block. But that's fine. I'm going to leave this armor stand here. I'm going to go destroy this little block over here. But yeah, now I could run this over and over again. Oops. And it will kill the existing armor stand and place a new one there and place a piece of white wool above it. So that's fine. But now that we think we've corrected this, let's try running this again. All right. And we are not placing any wool at all. Although the armor stand does appear to be going 64 blocks out that way, and then moving down to the next row and starting over again. So that's good. So let's try to figure out what's going wrong again next. Well, the blocks that actually place the wool are down here at the end. This is another unintentional bug that I introduced, other than the intentional ones. If you look at the previous output here, it says unknown command, try/help for a list of commands. When that happens, that usually means you've misspelled something. And if I take a look at this, sure enough, I've misspelled execute. I had execute. And so if I spell this correctly, and then since I copy pasted it into this block, it's probably spelled incorrectly here as well. That's probably what the problem was. And so we'll go ahead and respell those correctly. We'll run our little reset kind of thing to kill the old armor stand and reset it. And try this again. Aha! And now we're placing the carpet, except for it's not exactly going in the right spot. Each time it's actually going one back over further than I intended it to. And over on the other end, yeah, similarly, it's probably going to be stopping one shorter than I intended it to. And this was actually a bug that I did intentionally introduce that I made the first time around. Scoreboard players test when X is greater than or equal to 64, basically between 64 and infinity. I want X to run from 1 to 64. It's actually when X reaches 65 that then it's time for us to cycle back around. And so what I need to do, this is a classic kind of off by 1 error. Anytime you have loops, it's very easy to get the boundary conditions just off by a count of 1. And so X from 1 to 64 is fine. When X reaches 65, that is actually when I want to go and reset the loop. And so that, I believe, is the problem here. You'll notice now if I reset my initial conditions, all of this wool is still here. And I would like to erase all of this wool as well. And so a good way to do this, I can't recall in a previous episode if we've actually seen the fill command. But basically, if I do a set block here and do tab, 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 tab to complete the coordinates. I mean, I could set it to wool 0, for example, the redstone block that I'm looking at right here. But once I know the coordinates of this thing, and I know that this is positive x and this is positive z, I am going to go grab those coordinates and do a Control-C so that I've got them in my kind of cut and paste buffer. We're going to add something else, the initialization command. Can't remember if we've actually done a fill command before or not. But we're going to do fill. And starting at these coordinates, 859.65 was that redstone block. And I basically just want to go like 100 blocks in the x direction and 100 blocks in the z direction and change it all to air. So I'm going to go from 8 to 108. Y of 59, everything's going to be at the same height. And z from 65 to 165, I'm going to fill it with air. And so basically that's going to take all the blocks, starting at this block and going 100 in the x and 100 in the z, that big square up here in the air, it's going to fill it with air. And so if I run this now, all those blocks disappear. And so that's great. So every time we make a mistake, painting blocks the wrong color, we can just run our initialization and it'll erase those blocks in the sky and we can start over with kind of a fresh canvas to draw on. So that is great. And we did just change this to 65. So let's try running it again and see if it at least now is going to do this. And right, okay, here is another little bug that to some of you it may already be obvious. But basically my previous initialization, I put the white wool there and then I put my cleanup thing at the end, and so it cleaned up the first piece of white wool. And so basically the very first square when I first initialized the armor stand was getting placed here. It then got erased before the loops started going. The loops are now correctly lining up so that we start in the same column each time. But basically we want this cleanup to actually go at the beginning rather than the end. And so once again we can use nudgeZ. And so I'm going to move these blocks over. And then I'm going to make a copy of this fill command and place it back over here near the beginning rather than the end. And so now if I run the initialization command, we'll clear everything first and then set that piece of white wool. So after all this time, we've successfully made a square and done nothing else. And here's another unintentional bug that I did, which is the first square is supposed to be black rather than white. All right, maybe I shouldn't have introduced intentional bugs because I've made enough unintentional ones to really keep us going. So the first square in this whole thing is supposed to be black, and that ends up changing a whole lot. So let's do this. Wool 15 rather than wool 1 is black wool rather than white wool, and that should change a lot in terms of how this runs. But it's still not going to. We're still getting all white wools. And that's because there are still other bugs. And so the very second wool should be a black wool because it should look one above us. There's not black wool there. In fact, there's nothing there. There's air there. One to the left of us, there is a black wool. And so the count should be 1. And so as a result, with the count of 1, it should be putting down a black wool. And so now here is another bug debugging strategy that I want to share with you all, which is rather than running the loop over and over again, just kind of stepping through the loop. So I've initialized things, and now I'm going to change this purple repeat block to an impulse block, because by doing that, rather than running this over and over again in a loop, what I can do is I can run one iteration of the loop, and then go and inspect different values and try to figure out what happened, and then run another iteration of the loop and inspect the values and see what happened until I understand what's going on and I'm able to fix the problem. So that is basically going to be our strategy. Let me reinitialize everything, and then let's run one iteration of the loop. Okay, we got a white wool when I was expecting to get a black wool. And I noticed that it says count over on the scoreboard on the right-hand side is 2. And count was supposed to be summing up how many black blocks we saw above us and to the left of us. And that doesn't seem to be working. So let's see, where were these things? Right, here's where we're testing for a wool that is -1 in the z, which basically is this direction, so kind of above us. And if so, we're going to add 1 to count, and this one is testing 1 to the left of us, and if so, we're going to add 1 to count. And I see this one, for example, says set score of my objective for player count to 2. And this one also says set score of my objective player count 2. That one says at 1335, and that one says at 1337. So as a side note, this is something interesting. It's only when commands are run and only when certain commands are run do they ever populate this previous output. And so it's important to look at the timestamps to figure things out. This one is a few minutes old already, whereas this one actually ran recently. So I think this condition did turn out to be true, but this condition was actually false, and it was sometime a while back that we actually got output there that was true. But in any case, if I think that this correctly, yeah, it even says here, failed to execute test for block. Oh, as Lorgon 111. Oh, as Lorgon 111. It shouldn't be, here we go. Here is the same bug that I had last time, which is, I didn't say execute type equals armor stand. So that's a problem. It was looking relative to me rather than relative to the armor stand. So that was definitely a bug. This one is doing the exact same thing. Should say type equals armor stand so that I just fix both of those. Yes. All right. It's another unintentional bug. But this is the process of programming. When you're doing it on camera, apparently you make even more mistakes as you're trying to type quickly. Okay, but it's still not working. But now I think I know why. All right, so let's run this thing. It says count is 2. And so let's go back here. At these things, we could be adding 1 to count here and adding 1 to count here. But over here, scoreboard players set count. I'm trying to initialize count, but I'm initializing it to 1 rather than initializing it to 0. And I really want to initialize to 0. And then if there's a black block above me, add 1. And if there's a black block to the left of me, add 1. So I should have 0, 1, or 2 blocks. But I was initializing it to 1, and so my count variable was going to end up taking on values like 1, 2, or 3. So let's fix that bug by initializing count to the correct value and take a step. And now on the right-hand side of the screen, count is 1, but it still ended up placing white wool instead of black wool. So you recall down at the end, I test count, and if count is exactly 1, score 1 is in range 1 to 1 at 1:40 p.m., and that's the current time, so this did just run. And if so, put a piece of black wool above us. So it actually did that correctly. And so what's going wrong? Then we do our else. And so our else didn't happen here. Oh, I see the problem. And this is actually a problem that I made this morning and introduced intentionally here. Then, at 13:40, once again, just now, it places white wool. You see what's happening here? This block is conditional, but I forgot to make this block conditional so that it only runs in the else, so it's always running. And so even though we just placed a piece of black wool above the armor stand, we then went and overwrote it with a piece of white wool above the armor stand because this one wasn't conditional and it's supposed to be conditional. So if this is true, place black wool, else place white wool, but only do one or the other of these conditionally. So having fixed that to be a conditional block, now let's go and try running this again. All right, and now it's placing black blocks, which is the correct thing. And so maybe we've got it all working at this point. And so I'm going to change this back to a purple and now see if it's actually working. And I think it might be. Let's go fly over the top. But yes, this is the expected pattern. This is the pattern of Sierpinski's triangle. And so we've managed to make it after correcting a whole lot of errors that we had along the way. And yes, that is, in fact, how programming works in the real world. I can say with some confidence, as someone who worked as a software developer at Microsoft for close to 10 years. And yeah, whenever you program things, you almost never get it right the first time. You will write some code, and then you'll have a bunch of bugs. As you get more experience in a particular programming language or programming medium, in the case here is Minecraft, you'll make fewer bugs along the way, but there's always going to be bugs, and then you have to be able to go and debug what has gone wrong. And so the act of doing the debugging, the act of inspecting individual values and statements that you've made, figuring out where you've made mistakes, stepping through loops one step at a time rather than running them over and over and over again so that you can kind of figure out what's going wrong, is what you do. But you can see we're making this beautiful pattern that was the homework assignment for the previous thing. So we could call this done, but there are a couple of other debugging, I don't know, tips and strategies and different things that I want to show off for you guys. And so let's talk about them. So we already saw a good way to debug a loop, which is to change a loop that's running continually into something that will just run once, so that you can run it once and inspect the output, and then run it again and inspect the outputs. So that is a useful thing to do. In this case, we only had like about 15 blocks in a chain here, but as you start writing more complicated command block programs, you may have, many more command blocks. And it might be the case that you want to test and see if things are going well up to here, and then the stuff that's down here maybe you don't care about just yet. And so nudgeZ can also be useful. So let's say, for example, I don't even remember exactly what's going on in all these commands, but let's say I think I had some kind of bug, or I wanted to inspect the output just in the first half over here. I could just insert some space, and now if I run this, it's only going to run these commands up to here, because then the chain is broken. And so I could inspect the output. I can inspect scoreboard variables over on the right-hand side. I could take a look at some of the previous outputs in some of these command blocks if I wanted to see if things are going right or wrong. And maybe I would find a problem, or maybe I wouldn't find a problem, and maybe I'd misguessed, and actually the problem is somewhere over here. So if I want to step through that, I could just introduce another orange block here in the space that I just made, and go run the second half of the loop over here. And I could do that a few times to kind of like step into the next iteration of the loop and run the first half, and then run the second half. Just to make sure, if you are trying to introduce space and then run pieces of the loop, that the space you introduce is always before an unconditional block as a place that you break the loop, because otherwise you'll kind of break some of the if-then-else conditions that you're trying to do. And then once you're done debugging, we can just place a redstone block here and use nudgeZ to move that whole section right on back in order to start running the loop the full way through. And so that is one debugging strategy for just trying to run a portion of a big section of code. And then another debugging strategy is to introduce some output into the chat. And I don't know that I have a good example to do on this one. So let's do this. The first thing we were doing is testing if x was 65, and if so, we were going to kind of like reset it back to the beginning of the line. Otherwise, we were just going to move x over by 1. And let's say I wanted to test while the loop was going whether that was working properly. I can use nudgeZ here to move things over and make some space. And I'm going to add a conditional command here where I'm going to say x was greater than 64, at least 65, resetting to next line. Some big amount of text over there. And then in the else condition, else over here, I will use nudgeZ to move this over, so I can introduce a say over here as well. And over here, I'll just say x plus 1, because that's going to be the common case. And just to show how this works, if I start running this, most of the time it's printing x plus 1, but every time the stand gets to the end, you'll say it prints out x was greater than 64, resetting to the line. And so in this case, yeah, it's not particularly interesting, but if you have stuff going in a loop and you're trying to get a sense of whether something is working and it's not as visual as the stand being teleported back to the beginning of the loop, then it may be useful to put in debugging output in the loop like this so that you can see the debugging output in the chat, and you can kind of scroll around in the chat to see if you're getting the debugging output that you expect. And so that's a common programming technique in any programming language, basically to introduce extra kind of print statements that print out some output so that you can use those print statements to kind of debug what's going on. And I just realized I forgot to make this one conditional, and so it was printing x plus 1 even when we did go to the reset line. But then once you're confident that that piece is working, Once again, you can just break the blocks that you don't need anymore, those debugging print statements that said something in the chat, and use nudgeZ to erase it and move everything back over. And then, yeah, here is the say x plus 1. I'm going to break this one as well and move everything back over. And yeah, those are a couple of other debugging strategies for just being able to run a portion of one iteration of a loop and then run another portion as you're trying to just debug individual segments, as well as inserting print statements into your code so you can kind of get a sense of what's going on at different points in time. But at the end of the day, we got this whole thing running and working properly. And let's see how much time there is left in the episode. This ended up running longer than I expected because I made more mistakes than I intended, but I think that ended up being very informative, hopefully for you all, and so you learn various debugging techniques, and also see that it really is the case that even if you're someone with a PhD in computer science who has been doing software development for many years, you are still going to make these mistakes, so don't feel bad if you're making them as well. Debugging is very important, and I feel like in general, in programming course curriculum, it's often the case that even when you're learning programming in school, they focus on how to do things right and don't spend enough time teaching you how to fix things when things go wrong, which is a very important skill. So hopefully you're learning things regardless. Yes, this will definitely be long enough for today's episode. So let's just kind of sum up what we have learned. Basically, I had a program in mind that I wanted to write, and we'd done something kind of similar but a little bit simpler before, and so I tried to kind of map it out using the same strategy. I set up some initial conditions, because then I had something that wanted to run in a loop. I kind of planned things out in my head in terms of we needed to figure out where to teleport the armor stand, we needed to decide what color wool we wanted to place, and then we actually needed to place the wool, and we're going to do that over and over again in the loop. Then I tried to write code for all of those pieces and put them together. Then I ran the thing and it didn't work. And so I started looking at the different commands and debugging based on the different ways that things weren't working. And while debugging, I changed loops from repeat command blocks to impulse command blocks. So we could just run one iteration of the loop at a time and then kind of inspect where things were going wrong. I spent a lot of time kind of peeking inside the command blocks. And yeah, next time there are some other commands that I want to show off, other ways that we could make this not necessarily more efficient, but slightly simpler in terms of the number of command blocks it takes to write, and then show off some other Minecraft kind of goodies, because some of the next things that I'd like to do in the next episode involve doing things with Minecraft and kind of animating fun things in the world, but we'll see how quickly we get to that. I hope, as always, that you guys are having a great day. I am Dr. Brian Lorgon111, and I hope to see you again in the future as we continue to learn more about programming command blocks. Bye-bye.